In this problem, we are going to use simulation to test hypotheses about a population proportion. So take a moment to pause and read this problem statement. The first thing that we're asked to do here is identify the variable of interest in the study, whether it's qualitative with 2 outcomes, and explain. So here our variable of interest is whether or not an adult is optimistic about the future. That's what they were being asked about up here. So therefore it's either a yes, they are optimistic, or no, they are not optimistic. So that is a qualitative outcome, 2 possible outcomes that are qualitative. So then the goal of the research becomes looking to see whether our population in this country who are optimistic about the future is different from 0.07. So that was previous survey results told us 70%. But this question, after one other smaller sample or survey more recently was conducted, suggested otherwise. So now the question is there evidence to suggest the proportion of adults in the country has changed? So is it different? Now, how we write that as a null and alternative hypothesis is like this. So we're going to say, is this population proportion, or this is our null hypothesis, that the population proportion is 0.7, sorry. And the alternative hypothesis is that that proportion is different than 0.7. So just not equal to 0.7. Okay, so after this, now we're going to turn to StatCrunch and use the EARN sampling in order to create a simulation and find a p-value and see if there's any significance to that recent poll. There are a few things that we can do first. We can determine the number of red and green balls in the EARN. And here we're told let red represent the number of optimistic adults. So again, remember, we're assuming 70% of our population are optimistic. So in other words, they're red. So I just came over to my calculator real quick. I did 70% of the population. So that should be the number of red balls in the EARN. Those not optimistic then would be what's left, or 30% of the population. So here's the number of green balls in the EARN. So that's how we can determine those values. We can already go ahead and fill this in. We know that we want to draw the same sample size as our recent poll of 600 adults. We were told to do this sample or do not draw with replacement. That was told to us up here. As far as the left tail and right tail conditions, for the left tail, we want to know if it's less than or equal to 390. That was given to us here, but what we need to see is how different is that from the 70% of 600 adults. So let's come back to our calculator. And let's do 70% of 600. So this is what ideally we should have seen from that poll if it exactly matched the population previous survey of all the country's residents. We should have seen 420, but instead we saw 390. Okay, so that is different by 30. Okay, so now we want to see is how different would it be on the right side. So let's do that ideal 420 and let's add 30 to that. So this is how different, if it goes further than 450 on the right side, then that would be that condition for the right tail test. Okay, so that's how we get these values here. And I think next what we need to do is just run the simulation. Okay, so I'm going to start by going to Applets, Simulation, and EARN Sampling. we determined the number of red balls was going to be 100 and, oops. Okay, like this. And then green, we determined that one earlier. The number of balls to draw was the sample size that we had, which was 600. We were told not to draw with replacement. That was just given to us in the information above. Let's start with the left tail. So the condition for the left tail is less than or equal to 390. We were also told to use a fixed seed. Again, we're asked to use a fixed seed only because then our answers will match what my math lab is looking for. Okay, so in this particular case, this is our fixed seed. Let me just make sure I type that in correctly. Okay, we compute. Okay, we were also asked to do 5,000 repetitions of this study. So let's do 5,000 repetitions. Okay, and at this point, I have a p-value of 0.0044 on the left. Okay, that's that left tail, less than or equal to, number of red balls is less than or equal to 390. Now, I also need to do the right. So I can go ahead and do that right now. I'm going to keep in mind this number. I'm going to go ahead and write it in my calculator. Okay, and I'm going to come back here and do the right at 450. Notice I don't need to rerun the simulation. It's just highlighting a different space in my model. Okay, so now I have 0.0036 on the, what did I just say? I think I said left, but I meant to say right. Okay, so let's add 0.0036. So together, the left and the right tail gives us this p-value, 0.008. Okay, so notice that's what happens here. The p-value is 0.008. So put in another way, if the study was conducted 1,000 different times, one would expect to observe a result as extreme as 390 or fewer. Optimistic adults out of 600 in about 8 of the studies. Actually, I would say as extreme or as different really is probably the way that should be stated. That might be part of what that was a question there because it was left and right tailed. Okay, so now we're asked to do this again, but with a coin flipping app. So some of this information we can go ahead and answer, like what does each coin represent? It would represent a single adult. A head is an optimistic adult. A tail is one that's not optimistic. Okay, so the probability of heads we will have to change to 0.7. Again, that was our population proportion. We will flip 600 coins. Again, that comes from that recent sample. Notice that the left and the right tail conditions stay the same here, but we're just going to rerun the simulation in a different way. What we're hoping to find, and it looks like we will find, is that the p-value is the same or nearly the same, especially whenever we use the same fixed seed value. So let's just go through that process of using the applet for coin flipping. So I'll go to simulation, coin flipping, change that probability of heads to the probability of being optimistic. Number of coins is that recent sample size. I want to first look for less than 390. Using a fixed seed of 11,718. Okay, compute. I think we were also asked to do another 5,000 repetitions. Okay. Okay, so 5,000 repetitions. Keep in mind this proportion or p-value right here, 0.005. Let's now change this to greater than or equal to 450. And now we have 0.0032. So when we add those two together, 0.005 plus 0.0032. Really close to the same p-values we had with the other simulation, but rounded to 3 places is where we get 0.008 for the p-value. Still means the same results as well. So based on 2 different simulations here, but that basically told us the same thing. Not surprising that it told us the same thing. We would still reject the null hypothesis because this p-value is so low. It is less than that significance level of 0.05. Remember, it was 0.008. So that means that there is significant evidence to suggest that the proportion of adults in the country who are optimistic has changed from 0.7.